Here we will see about differential type buck boost inverter for single phase and three phase applications. This is the differential type buck boost inverter, that is conventional. And here we have, this is the proposed differential type single phase inverter. In this, the voltage source is provided DC voltage source that is given to this 2 ohm branch for positive cycle, and for negative cycle same another branch is used. So totally two inductors will be used for positive cycle and two inductors will be used for negative cycle. When the switch S1 is on, the inductor L1 will be charged at the time, L2 will be discharging, and when the switch S2 is on, L2 will be charging, L1 will be discharging. Similarly for L3 and L4 for negative cycle. Okay, by this the capacitors, we will get the differential voltage. For positive cycle, here across C1 we will get the voltage, and for negative cycle across C2 we will get the voltage, and from that across the load we will get differential voltage that we can see in this simulation. Single phase, in this input voltage we have provided as 13 volt, and here the capacitor values are 0.39 millifarad, and here we are using the switching pulses, that is we are generating the pulses with the help of these waveforms, reference waveforms. Okay, these are reference 1 and reference 2 waveforms that we are comparing. We have to modify the sine wave like this. For positive cycle, reference 1 will be used. For negative cycle, reference 2 will be used. We will compare the high frequency triangular waveform with this modulation signal or reference signal, and from that pulses will be generated and provided to the corresponding switches S1 and S2, S3 and S4. From that we will get the differential operation. In this, if you see, means the voltage across the capacitors and the output voltage. Output voltage is provided here, and the voltage across the capacitor Vc1, capacitor Vc2. If we zoom it, we can see the capacitor 1 voltage. When it is 0, capacitor 2 voltage is appearing, and when capacitor 2 voltage is 0, capacitor 1 voltage increases. So from that we will get the differential voltage. And here these are the input power, output power and efficiency. We have designed it for 100 watts. Efficiency is around 98.81 percentage. This is for single phase application. For three phase, we have to combine these three and provide the phase shift. For phase A, the phase shift is 0. For phase B, phase shift is 120 degree, and for phase C, it is minus 120 degree or 240 degree. So from this we can generate the pulses and give to the corresponding phases, and here we get the capacitor voltages. The capacitor voltage for three phase is provided here. Here these are the capacitor voltages, and these are three phase voltage. Okay, these are the three phase voltages. and here we will get the efficiency along with load power and input power. Load power is around 85 watts, input power is around 105 watts, efficiency is around 82 percentage. So here efficiency is 82 percentage for three phase applications. For single phase it is 98 percentage. Just by creating the differential voltage using these capacitors, we will get the output voltage. And by increasing or decreasing or by controlling the capacitor voltages, we can control the load voltage. That can be controlled by varying the amplitude of this reference signal. So this is the working of single phase or three phase differential inverter.